Okay guys, let's proceed with the component of vectors in terms of unit vectors. What does it mean by component of vectors? That is the first thing that you need to be clear with. Okay, the component that you have in one vectors, okay, is this. Okay, so in writing the vectors, right, it should be written down in this pointy kind of bracket, right, where you have x, y, and z for the three-dimensional vectors. Alright, so if your vector is three-dimension, you will have x, y, z. That also, if you can imagine, this just you should have three axes, x, y, and z. So those are the components. And if you want to write it down, right, it is actually the equation for it. So you have x I plus y j plus z k. Okay, so if we, just like what we have learned before, this symbol here represents a vector. But what difference here is that this is a unit vector. So unit vector is actually a vector that that is in one unit. The unit of each vector for I, j, and k here is 1. Okay, if we convert a vector later in a form of unit vector, right, the length later of that vector will be 1. Right, if you have learned before, the length here, this length can be vary. Okay, but once you have changed into in terms of unit vector, we have a formula for it later. The line will be 1, standardized. Right, let me show you what does it mean by that. This is an example of x, y, the unit vector, where as you can see here, right, this is 3D where you have x, y, and z. Okay, this length is actually equal to 1. Right, this length is equal to 1. So if you convert any vector into unit vector, you will get this line, which is 1. Okay, so for I, the unit vector is 1, 0, 0, of course, because x is 1. And for j, y is 1. For k, z is 1. So hence you will get the magnitude of 1. Okay, so that is for unit vector. We are going to discuss further about it later, where you need later to convert your vector into unit vector. Okay, so let's see how does vector in two-dimensional look like. So okay, first let's be clear on this. This is not a vector. This p here is not a vector. Just look at the bracket here. It is actually a round shaped bracket. This is just a Cartesian coordinate. So what's different between this and vector? So first, the difference, of course, in the bracket. But how can you get a vector? What is the difference of vector compared to a coordinate? For a coordinate, it is just pointing the location of certain coordinate. For example, this p here located at this point. As for when you look at the coordinate, you'll know that this is p. This is the location, and out of in overall graph, there's only one location of p, which is here. You cannot have the same coordinate at different location. That is impossible for Cartesian coordinate. As for vector, okay, the value of vector did not really indicate a location per se. So look at this. So the vector is 5, 3. Okay? If you want to put it in a form of coordinate, right? It should be written down. Right, let me set it up. Okay, 5, 3 here will be written down 5 3. Okay, so what is the difference between this 5 3 and this 5 3? Okay, this is the coordinate of 5 3 where it is located here. And is it possible for 5 3 to be maybe at other location? No. This is the location of 5 3 and this is the only location of 5 3. As for this one, 5 3 here is not the coordinate. This represent the vector. So if you look at this, okay, this is the coordinate of 5 3 and this is the vector of 5 3. So the vector of 5 3, the vector here represent the differences, the difference on x and y. So if you calculate from the origin 0 0, okay, the vector of 5 3, which is where the difference is 5 and 3, should be at this point. Okay, so let's try to move to other try a different kind of situation. Let's see whether you can have a vector in different location or not. Okay guys, let's look at this example. Okay, I'm using the example of 5 3. Okay, this 5 3. So we all know that the coordinate of 5 3 is at this point. Okay, so if I were to write down 5 3, okay, you'll see this is where it should appear, and this is the only location that you can have 5 3. As for vector, the value itself did not talk about the location. It talked about the difference between two locations. So for the first one, if you look at this example, you have 5 3 here at this point, the same as the coordinate because it starts from the origin 0 0. So of course the difference here, 5 minus 0 is 5, 3 minus 0 is 3, so it should pointing out at the same location of 5 3. Let's look at other situation. Okay, now this is the example in our book. As for this one, as you can see, the length is the same, the direction is the same. This is also vector 5 3 actually, but why it is actually being displayed at a different location? Because it starts at a different location. For this one, it starts at 0, so the difference is 5 and 3, so this is where it ends up. As for this one, it starts at 2 2, so the difference of 5 and 3 should end up at 7 5, right? 5 and 7 and 5. As for this one, because it starts at negative 5 2 here, right, the vector 5 3 should be at this area where it pointing up to 0 5, right, the difference of 5 and 3. I hope that you get the idea. Vector is not the same as coordinate. Okay, in vector it did not show the location, it actually show the differences of x and y. Okay, so this is for 2 dimension. Of course, it involves only x and y, and it can be written down in this form, 5i plus 3j, right? So it indicate the difference is 5 and in x, and the difference is 3 in y. Okay, and this is how you refer to it graphically. And next we have vector in 3 dimension where you have x, y and z. Okay, so this is how you write it down. You have the value of x, y and z. Okay, let's look at the example. Okay, let us try to see it through our actual graph. Okay, this is how 5 3 6 look like. vector 536, right? It pointing out to 5x of 5, and then we have 3 for y and 6 for z. It is actually not easy to draw it, draw 3D, right? That's how we have later for some formula to just calculate it when it comes to 3D. Okay, now let's look at the position vectors. What does it mean by the position vector? So the position vector of the point with coordinate x, y, z is this, where you subtract the coordinate of x, y, z with the coordinate of the origin. So you'll get the position vector. Alright, so if let's say somebody asks you for a position vector, it is simply a vector from the origin. Okay, where you need to subtract the coordinate with origin. So basically you should get the coordinate should be the same with the vector, because the origin is 0, 0, 0, right? For example, this 536 here is the coordinate, right? The vector of 536 is simply 5, 3 and 6, because when you start from origin you subtract with 0, so the length here should also be 536. Okay, that is position vector. Now, components of vectors. If PQ is a vector with initial point A, B, C and terminal Q is okay. So how to determine the component of vector? Okay, if you have follow this definition, right? Let's try to do the example. You will need to subtract. So they give you coordinate 1, 6, 3, and then B 4, negative 2, 7, and C 9, 1, 3. Okay, are the 3 points in R3. Okay, this is, it shows this is 3 dimension. Find this. We know that this is actually the notation for vector A to B. So to find vector A to B, the correct way is to actually convert all of this into vector. Now this is a coordinate. If you just subtract A to B, you just subtracting the coordinate. By practice, it is not correct, not right. So you should first convert it into a position vector, which is by doing this. Of course, you should get the same value. For example, to get the vector of AB, you will need to subtract B to A, right? So B, vector of B is this same value, different bracket, because it becomes vector. And then for this one, A, like this, you subtract, you will get the difference between A and B, right? So B minus A, you will get this. This will be the vector, right? As for CA, to get the difference, of course, A minus C, right? A minus C. So you get this is a difference, and that become the vector of CA, right? So that is how to find the component of vector. Okay, next you have the magnitude or length. The good news is that to find the magnitude of this vector, the formula is the same as finding a modulus, which is also the length, right, in chapter 1. So this is the formula. For 3 dimension here, you just simply square and sum x, y and z, and then square root, so you get the magnitude. Okay, for example here, for 2 dimension, you have 3 and 4 as the vector of x and y. So to find the magnitude or the length of the line, right, the length, just do this. So the length of U is 5, and for this vector the length is 62, right? So that is on magnitude. Okay, thank you.